So we're gonna discuss about extreme programming in extended reality. Hello, I'm Akshay Arora, application developer in ThoughtWorks Gurgaon, and with me is Neil.
Yeah, I'm also an application developer here at ThoughtWorks.
Yeah. So, okay. So before jumping into TDD and these fancy terms CDI, CD, and all, let's first see what is extreme programming, right? So extreme programming is basically a software design methodology which basically focuses on improving your code and the output better, and also improving your responsiveness to the changing customer requirement, right? So it has some set of values, principles, and practices. So for us as a developer, the value is clean code and a better code and a better output. And there are certain ways or certain principles, you can say, to achieve these values, right? Principles like TDD, CICD, pair programming. There are certain principles to do that. And then we have principles which basically helps us to achieving these principles, right? So this is extreme programming. Let's move on to our first extreme programming practice, which is TDD. TDD is basically test driven development, which basically says that you need to write the test first before writing the production code, right? So instead of directly jumping into the production code and write all the logic and all, TDD says that you first write enough code, enough test for that production code, right? So it's basically relies on a very fast and small development cycle, which basically of testing, coding, and refactoring, which is also known as red, green, and refactor development cycle, which says like it has 4 steps. First step is like you need to write enough failing test before you write the production code, right? And then the step 2 is you need to write enough code to make that failing test pass. And then the third step is you need to refactor that code if needed, right? And then the fourth step is again we need to write the write you know multiple tests, other test for that. That is red green refactor development cycle. Now we know what is TDD, but what is the need of TDD? Why do we need TDD? Why do I say it will improve our code quality, right? So TDD basically, if you follow proper TDD, test-driven development, then you might have fewer bugs because uh, you will write test for all of your method before writing the production code. So you will have in things in mind that okay, I need to test this, I need to test it, so that it will eventually result in fewer bugs. And then the other advantage is you will have a live documentation of your whole code, right? For example, if you're writing a method for let's say sum, right? So you will have all the document live documentation of that method, like what this method do, what it does not do, right? And then if we want to refactor that code, then it will give you a very high confidence that okay, this unit tests are having my back. I can just safely refactor this thing, right? So if anything, if I make a mistake, then unit test will fake, and I get to know right there that there's something wrong in the refactoring. So isn't it a really cool tool or technique that that alerts us if we make a mistake right there, right? Then we have some types of tests. If you can see this test pyramid, the base layer is unit tests. Unit test basically focuses on the code that you write, right? For example, the method sum. So you will write enough unit tests for that particular function. You just no need to test for any other thing. And then sometimes unit tests aren't enough. Sometimes your code needs to talk to some outside world, right? Some other class or something. Then in that case you need integration, and your team, for example, your team is working on multiple modules that you need some integration, right? But there you need integration tests. And then on the top of the pyramid we have functional tests. Functional tests is basically our end-to-end testing of a feature, right? So we have these kind of tests in the Unity. Let's move on. How can we use TDD? How can we achieve TDD? How can we test our XR applications in AR/VR using Unity? What do you need?
Okay, so let's get into the actual nitty-gritties of how TDD and all of that stuff works. But before that, some disclaimers. For the next part, we'll be using Unity to show how you would write tests and all. And the basic different types of tests in Unity are edit mode and play mode tests. Now, edit mode just means that it runs on the editor application's update loop, which means that it runs inside of the editor and doesn't get into the gameplay loop cycle. What the gameplay loop is where your application actually runs. So if you want to test things like your editor scripts or inspector and stuff, you would put it inside of editor state tests. While if you want to test the actual logic of your application, you'd probably put it inside your play mode test. With all of that theory out of the way, let's actually get into a demo. Okay, so what we have here is a very simple project. If I run this, you would see that this is actually a VR project. I'm running it in the editor currently. So it's an empty space where you can look around. You have this rotating cube for some reason. And these are essentially buttons. You can gaze upon them, and clicking on them essentially changes the color. Now, to get into how the project is structured, there is this scene that is kind of where all of your objects and all of your code is like running. There are certain scripts. This color picker script is the script that is attached to change up the colors. And we also have a test assembly. Currently, the test assembly is empty. We'll get into that later. Now, inside of your canvas itself, we have the actual scripts, and each individual buttons link to an API for this script called change color. What they pass is essentially a string red. So red corresponds to the color red, and so on. Now we'll get out of the actual running state of Unity and we'll dive into the code. So this is the class that we were talking about, the color picker. Now, as you can see, the class is already written. So it's written mainly because to show the demo as to how the finished product might look like. But in order to do it in a TDD fashion, what we'll do is we'll start from scratch. So we'll start by deleting everything other than the actual API. For those of you who have actually worked in Unity, you know why I'm not deleting the API, because references will get removed. Okay, so this is essentially the bare minimum that you might have. So as Akshay mentioned earlier, TDD starts with a failing test. And in order to have a failing test, you need to write a test. And in order to write a test, you need a test file. So we'll start with a test script called color picker test. Okay. So once the file gets loaded in, it's an empty file. Now you can see that there are two default tests here. One is the normal test annotations and another is unity test. Unity test just means it runs on the playback loop. Normal test just runs in a different thread spawned by n unit that is running behind it. So let's say we want to start off with a test. So we'll start off with the unity test annotation. We'll write a very simple test here. Let's say it should set to red. Okay. Essentially what this test is telling us that it should set something to the color red. Now what we want to test here is the color picker. So we need an instance of this color picker. Now of course we won't create a new object, but we'll attach it to a game object. What game objects are in Unity are just objects that you see inside of your scene or application, and to which you can attach scripts and functionality and behavior that you can later on use. So we'll start by creating this new color picker, which we'll be testing. Now this color picker has something of an exposed variable, object to color. Now we'll set this as a very primitive cube object. This is our test object. This is the object we'll check to see whether like our test ran or not. So we'll put it inside of a variable, and we'll just call the API on top of this color picker. We'll call the change color and pass in the parameter red. Okay. So the first part that we set up is called the given. So our test can be divided into three parts: a given, a when, and a then condition. So given is just the setup, when is the condition that you want to test, and then is the assertion or the condition you want to equalize it against. So we want the color to change to color.red, and what we'll check it against is the cube's color. Now the cube's color can be found inside of its renderer's material. So I'll do a get component dot material dot color. Yeah. And that's our first test. Now, as you might know, that TDD starts off with a failing test. So what we expect is this test to actually fail, right? Okay. Once this loads. And you can find this test runner inside of Windows General Test Runner. Let's start by running this test. So as you can see, the test fails. And okay, sorry, my bad. This needs to be unenumerated because it's a play mode test that would run on the that was using Unity test. So I'll also have to return null just to skip a frame. And now it should fail for the right reason. So this is why failing a test is very important. You need to know that the test actually fails when the correct code is not there. Okay, let's hope this runs through. Okay, now it fails and it gives us the correct reason. It expects a red, but what it's getting is a white. So now we can write the code that would essentially pass this test. So in TDD, you will write code like as much code as is required to pass that singular test. So what we'll do is simple. We'll get the material of this cube that is attached, and to its color, we'll set nothing from the color name, but directly we'll set up color red because that's the minimum code that is required to pass this test. And we'll run the test again. As we can see, we got a green test. So we completed two parts of it. We completed the failing test. We completed the fixing of that failing test. Now comes the refactoring part. Now, of course, a get component call is more of a search function, which is expensive. So you might want to remove this to something like a different variable and save it rather than using it multiple times. So let's put on a start method. Start method is a method that will get called once every time the game objects gets loaded, and we'll remove this and put it at a global level. And that's your refactoring done. And once you run this again, make sure that after every refactoring that you do, the test actually remain green and don't go red. So we'll just make sure this is green. Okay, that goes green. And so we have our first cycle of TD. Similarly, you would write multiple tests. For time reasons, I won't try to optimize this test, but you can remove all of this code into setup callbacks and functions. But we'll just add another test real fast, so not that fast. Oh, so we want it for blue, and we'll just set up the parameters. And what we have is another failing test. So once the test loads and they run through and it fails for the right conditions, we can actually fix it and add more logic to our actual code. So as you can see, our blue test fails while the red test passes. So now we can add more logic to it, and with time this will essentially evolve. So the minimum logic required to fix this test would be something like color name dot equals, maybe let's say we'll put in the static string of red. It gets red, it will take red, otherwise let's say it takes blue. And that would be the minimum test that is required to pass. Now I could run this, it will just take time. So that is how your testing cycles would be. Now, these are unit tests. So what unit tests essentially mean, I think Akshay has touched upon it just a bit, is that these are tests that will not be dependent on other classes. Unit test level tests are the tests that have like little to no dependency on other APIs. So let's say we have a different API, something like an eye custom color. Let's say this is a color that you don't really have. This is just an interface with no implementation. You can see that there are no implementations for this. This is never used. So let's say this is a test, this is a component that is being created by a different team, or it's a component that is given by an SDK you might not be in control of, right? And let's say that you need to like write your test around this API. What happens if this color, custom color is given to it? How does it work? So what we'll do is we'll start by creating a new API for this. Let's say it takes an eye custom color, and in true TDD fashion, we'll remove all the implementation. And let's say this is how your test should look, right? But there are no implementation, so this value is currently null. How do we get around problems like this? Well, what we use are substitutes or mocks. So currently I'm using the N substitute library, but you can use Dynamock or MOQ for doing the same. So what I'll do is I'll set up a new mock or a proxy object for this eye custom color, and we'll pass this in. And moreover, what you can do on mocks is that you can actually add implementations to it or results to that implementation. So for the get color, let's say it returns the color yellow, right? So now I can assert against this yellow, and my test will fail because it has no implementation, right? But I will get test custom object that custom class that has no implementation of it, and yet like be able to test out if the application works. So via things like mocks, stubs, spies, and all, what you can do is you can remove dependency on things like SDKs or like applications that some other team may be building. So as you can see, this new test of our fails. It expects yellow, but it didn't get it. So now with the mock and stub ready, we can actually fix this test and say that our material.color is equal to this custom colors dot get color, and thus we have an implementation or functionality based upon a class that is not even created, that has not even been implemented, just based off of how the interfaces are by the use of mocks and stubs. Okay, that's kind of what we wanted to cover in this part of the section. Now I'll give the control back to Akshay to take over for the next part.
Thank you, Neil. Hope you got the essence of TDD. If you have any question, please ask us in a Q&A session. Okay, let's move on to the next important XP practice, which is CICD. CICD is basically continuous integration and continuous delivery slash deployment. So, uh, for example, suppose that you are working on a project, right? Uh, and your team decides to,
Oh,
divide your project into, yeah,
sorry.
yeah, no worries. Divide your project into multiple modules, and then as a developer you completed your module, and like using TDD, and everything is running smooth, everything is tested working fine, and our team then decides, then okay, let's integrate our modules at some point of day, like maybe end of the week, Friday or something. So but then they miss one point. What about integration? Testing, right? Who is responsible for that? If integration of modules might result in some issues, who is responsible for that, right? Then you don't want to work on weekends, right? No one wants to work on. So for that, we have a solution like continuous integration. Continuous integration basically says that need to integrate your code in one shared repository, a Git repository, and then each integration is verified by an automated build and automated test. So what does this means is, by every commit or every push that you made, your code will integrate into the Git, and then a automated test will run via script on the CI server. That means every commit is production ready and tested on the CI only. So whenever you make a commit or something, your product is ready to deliver. Right. This is continuous integration. And suppose that you are working on an Android game per se, or enterprise AR/VR application, and you want to deliver the APK to your client, right? So after the CI pushes your code, or everything, like it passes the all the phases, like test, all the tests and all, then it we need to export the APK, right? So the continuous delivery basically ready your deployment, right? It will make your deployment or artifact ready to the customer with only one click on of your button, right? And then deployment is basically, it will just after all the pipeline, all the stages of production pipeline, it will just without any human intervention, it is just deployed to production, right? So this is CI/CD. uh, uh, can we move on to the next slide? Okay. Again, why CI/CD? How can it improve our things? So first of all, lesser bugs, because your with automated test in CI, you are already testing all of your code, most of the code, like you are covering all of it in TDD, and then you are just running the automated test before shipping to production. Second thing is, it is very easier to build for release since integration is pre-completed. So you don't need to wait for some day or something like to integrate your code. Your integration is already being done as you commit your code, right? And then you have a earlier feedback of your broken code. You don't need to wait for some day or work on weekends to fix your broken code. If you make a push, it will integrate to the shared repository, and if something break, then you will get an immediate response. The build will fail, and you will get an immediate response, okay, that something went wrong after this commit, right? And then you will have, yes, it results in reducing testing cost, and QA can focus on improving the quality of the product. And then there's one more important point: there is no pause of development, right? So there's no one who is responsible for integrating this code and all. You just keep working in, just committing your changes, and integration will done automatically, right? Integration and deployment is done automatically. You don't need to waste any time for that or pause for your active development. Sorry. And then after each commit, your code is production ready, right? As we discussed earlier. So your customer will also get as soon your artifact, your build, as soon as you commit your code, right? With the completed with all the testing completed. So say enough of talks. Let's see like how is it done in Unity, how is it like configured and all. Neil, you wanna share your project?
Yeah, let me take over. So we'll work on the same project actually. So this one, we already have our test written. As you can see, the test kind of changed. That's mainly because I reset the project in between the talks. But yeah, so what we are gonna do is we are gonna set up a local CI from scratch. What configurations we have here is a Bamboo CI, but it will work with any type of CI that you want to use, Jenkins, Circle CI, or even if you want to go for something like Unity's cloud build. This process for cloud build is a bit more streamlined, but your normal CI builds is probably what you will get for enterprise applications, mainly because enterprises tend to not invest extra on infra, but they would use whatever they already have. So we'll start by creating our first build. So yeah, and as the things process, let me tell you that the whole CI/CD pipeline is divided into two major parts: the server as well as the agents. What the server does is it pulls the code from the linked repositories and assigns different build jobs or tasks to the different agents. What are agents? Agents are the workers. So you can think of the server as the distributor while the agents as the actual field workers. So in the current setup, I am running a local Bamboo in my machine. So both the server as well as the agent is my machine itself, is my laptop. So let's get into setting up our first project. So we'll start with the Geek Night project. We'll call the plan test and build. No descriptions necessary. Now we'll set up a CI/CD. We'll set up the repository. Yeah, not CI/CD. So this is your version control system. For our example, we'll be using Git, but as you can see, you can go for numerous different types of version controls. What we'll call it is Git repository, Git repository. And for authentication, you would normally go for a SSH private key and provide a file, because you won't be having this setup on your laptop, but you'll normally have it inside of a server or a virtual machine on the client side, or maybe some infra side on the DevOps side, essentially. But for this one itself, this demo itself, we'll be going for our trusty username and password because it's fast. So let me set up my password. Hope it's right. And for Git setup, we'll take up the master branch. We'll also make sure that the connection is correct so that we don't have issues later on. I think I put in the wrong password. Let's test it again. And yeah, so now we'll get into the configuration of plans. So this is the project setup. This is where the project got set up. Now, what does a project in a CI/CD mean? A project is the accumulation of multiple plans. Okay, we'll go into the differentiations later on, but what a plan is essentially, let's say you have one application to build. So you will create one plan for it. And what the plan will contain is multiple jobs. Jobs are like independent units inside of your plan. And each of these jobs will have multiple tasks. Okay? Each of these tasks are the lowest, like the smallest unit inside of your CI and CD. So as you can see that a custom job is already configured. The minimum task is already there, that is to pulling of a repository. What I would suggest is to also use this checkbox, force clean build. What it means is essentially clean up my repository, clean up my check out new code, and we'll use the agents environment. Similarly, we can also use a Docker container for it. Now we'll start with the very first. We'll start with the very first script, first task, which is the test task. Okay, and for this, we'll be using shell script to set up the task. And I'll open up my trusty cheat sheet because I'm not going to remember all of this. I can guarantee you that. But what I will do is go through like every part of what this is. What this command essentially states is that it picks up your Unity executable. It provides the executable like arguments as well as parameters. The arguments are defined by the hyphens in front of it, while the parameters are the one following it. So it provides the project path. It says what needs to be done. It needs to run the tests. Then it says what type of tests it needs to run. We are saying play mode test because that's how our project was configured. It also tells it where to save the results once the tests actually run through, and also to print the logs and run them without any graphics and in bash mode, which means that your project or Unity instance will not open up with UI and not ask for confirmations or anything like that, anything like a progress bar or anything. So that's our first task ready. Now, what this task will create is essentially a XML file. But people don't read XML files, right? So what we'll add is an extra task here to read the XML files. Rather than going through the code, what we'll do is we'll let this in-unit parser task read the XML file and show us in a more representable manner. So I'll say results. This is the file that we configured in the last task, and I'll save it. So now we have our test script and an in-unit parser, which parses those test scripts. Finally, we also want to build our application. So for that, I'll add another script, and this will essentially build our application. Now, for this particular project, we are using Google VR for movement and all that. So we'll be building for Android. So it can run on any Android phone, essentially. So we'll call it a build API. Now, I'll copy the code section. Its code is unique in the sense that it still calls your Unity executable, followed by telling it where the project is. But instead of going for something like a run test, what it calls is this special argument called execute method. Okay. Before we get into what this execute method does, in case you're wondering where do you get all of these arguments, well, you can find it in Unity's manual. You can just search for command line arguments and you'll find all the arguments that are present. So that's how you configure your own build. What this execute method does, though, is picks up a certain script inside of my project and performs a certain function. What is that certain script? It's build command. And what is the certain function? Is perform build. So if we go into the project itself, you can see that there is an editor assembly here, and it contains this build command. What does this build command contain? Well, the build command contains the build process. So as you can see here, that execute command followed by build command dot perform build will link up to this function here. It has to be static for it to find it. But apart from that, it takes up a few of its custom parameters, and then it adds up the scenes. Finally, what the main thing that it does is it calls the build pipeline APIs from the Unity editor and builds a new player. What is this player? This player can be anything. For an Android build, it would be an APK. For an iOS build, it would be an Xcode project, and so on, executable for Windows, and so on. And what it takes is the scenes that it needs to build, where it needs to build the application to, what build target it should take up. We're giving it as Android as the default. And if you want any particular type of build, let's say you want something like a development build or something where only the scripts are built, you'd put the options here. Currently, we don't need any options. And once all of this, like this building of layer is done, it might succeed, it might not succeed, right? So if it succeeds, we'll exit the editor itself with an exit code of 0, which just means that everything worked fine. Anything apart from an exit code of 0 is considered a fail by more or less any CI. So whenever this returns back an exit code of 1, what this CI would do, it will say that, hey man, I have failed. Okay. So with that out of the way, that's essentially all you need to do to set up a pipeline. Now, as you can see, I'm substituting a few variables here and there, right? Some of these variables, like the working directory, are pre-configured. It's not something that you need to set up, but things like the Unity path is something you'd have to set up on your own. Now you can set up for the individual tasks, but most of the time you would set up for the entire project. So what we'll do is, once this is done, okay, let's go into the builds or build plans. Test and build. So this is the new plan that we just created. Okay, and we'll start configuring the plan. The first thing you can notice is that it's actually disabled. So let's fix that quickly. So we'll go into the plan details and enable it. Next, we need to set up the variables. Now the variables need to be set up at here. So this is where you would set up your Unity path, for example, and the value would be the actual path. Of course, nobody has the time to remember this. This is my Unity installation. For a Windows installation, it will end with .exe, the executable, and it will start picking up this Unity installation. Apart from these, the variables and the build plan getting ready, what you need as well are the artifacts. Now, what does it mean to have artifacts for a certain build? Well, artifacts are the products, what is created from your build. So let's say I want the test results to be one artifact, and I'll say that it comes in the form of result.xml, and it's not required. Maybe someone can run the build without having to need to run the test job. So we can add one artifact for that. Similarly, you can add another artifact. Let's say we want the actual APK to be the artifact this time. As you can see, it also takes wildcard characters. Maybe you want something like build number in between. So you can put in wildcard characters, it will pick those up. And with all of that done, we have our CI/CD setup. And all you need to do is run this plan. Now, normally you won't have to run it manually. It's good to check it by running it manually. But normally, whenever you would push code from your to your repository, like you do a git push, not force, git push, essentially it will pull in the data from the repository and trigger a new build. Now, of course, the polling happens over a period of time. So let's say it has a 5-minute polling time. That means that the CI instance will wait for 5 minutes, then pull the code, then wait for 5 minutes, and then again check if there is a new pull or not. So there is a time interval between them. Also, what you can notice is that Unity has gotten triggered. And if you notice the logs, Unity has started running, and we're going through the builds right now. Now, this is a bit of a time-consuming process. So let's take the questions. We'll wait for this build to actually go through, and then we can continue. Okay, it might take a minute or two. So, yeah. So in conclusion, what we went through today are mostly the whys and hows of XP practices in XR. Things like why is TDD or CICD required, and how it helps you in development and keeping your projects agile, and also how you set up your own TDD or set up your own CI/CD pipelines and builds and all of that. Okay, so yeah, if you have questions, feel free to post them. I'll stop sharing. And yeah, thank you, folks.
Thank you. Thank you, everyone.
I can only stop sharing. Yeah. So if that runs through, we'll look back at it once again. But if you have any questions, we are free to answer them now. So yeah, any questions, anything? Parallel agents. Well, we have a question about parallel agents. Agents. So agents, yeah, agents run parallelly. What agents do is they are distributed. So what that means is that your server can have like 10 plans, and the server will decide that let's say this agent is free to run this like build plan. So it will assign it to it. Now, if you have like 4 agents, then it will assign all 4 like different tasks to all 4 of them, and they will always run parallel. Now, there is one more thing that I can cover here is that normally your build plans will also have certain requirements, build plans or jobs. So let's go through this once more. Yeah, so your jobs normally have what are called requirements. What does this requirements mean? Individual agents might have different capabilities. Currently, I have one agent, my machine itself, and it will show you all the capabilities that my machine has. Now, if you have multiple agents, you can pick and choose what kind of agent you require for that build, and you can configure those here. So if you require a agent that has Unity capability, you can configure it in the requirements, and the server will only assign agents that has that capability to that build plan or job. So yeah, agents always run in parallel to answer your question. Any other, feel free. I seem to have lost my Zoom panel.
I think there's one question in the chat. Can you please talk about some of the projects you have delivered at ThoughtWorks, their business case and tech stack? Hari, you want to talk about it?
Yeah, very please.
I'm not sure about the business case. I can talk about. So a lot of projects that we're currently working on is all related to enterprise XR. How do we make sure that we can transform XR for enterprises? How do we make sure that it's quickly adaptable to some of the cases that we talked about it? So for example, the Porsche use case itself, like it's about talking about how do we make sure there's a remote expert, how do we start collaborating with them. There are interesting use cases that we're talking about. How do we bring in multi-user authentication into the devices so that it becomes adaptable for people there. So it's about the business case is predominantly on enterprise adoption, and how do we kind of make it clean and neat for enterprises to start using the XR devices for them. Because of client confidentiality, I cannot talk in detail, but this is at a high level, I can talk about it. Talking about the tech stack, I think Neil and Akshay should be the best bet, but I can talk about predominantly it is on Unity that we talked about it. Other things, Neil and Akshay, do you want to talk on the tech stack itself? What to use?
I can talk a little here. So use case primarily you covered. Enterprise XR is more than just the application development. It is talking about cloud development. It is talking about integrating with existing infrastructures like authentication, single sign-on across the application, across XR application, and talking about integration with CRM system, with ERP system of the organizations. So those are all those integration with XR applications we are doing. And apart from that, building SDKs for the platforms. Because when we say enterprise, most of the customers are trying to build the complete ecosystem where they can build XR development as a platform. So we are in that game of platform thinking around any product and how we can build platform which can enable multiple applications on that platform. And tech stack wise, primarily Unity, yes. But we are exploring a lot of things with Unity on AI, machine learning, can be integrated with Unity to simulate, having simulation environment, Unity ML agents and all. Yeah, so that's where. So when it comes to AI, it is all Python and OpenCV and other stuff getting integrated to Unity.
Okay, let me share one last time. So now that the build has gone through, we have a green build. And as you can see, all your tests would come under this inside of your test tab. Now, if the build was triggered by something like a push from someone, that would come on the commits. We ran it manually, so it didn't come through. The artifacts just give you a place to retrieve everything that was created during the plan. Logs are logs, and metadata is metadata. Field information and all that. So that's how you set up your CI in under 20 minutes, I think. So yeah.
Okay. You guys have to get into other meetings.
Okay, I'll stop sharing. Yeah, that's it for my side.
Thank you everyone for joining here.